वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल डिस्कस अबाउट स्पेक्ट्रा। टुडे द टॉपिक्स विल कवर spectra, then after that shapes of atomic orbitals, nodes, nodal surface. So these three topics we will cover now. So we'll start with the spectra. So what is the spectrum? So when a light crosses through the prism and we obtain it on a photographic plate, that is known as the spectrum. So a spectrum is basically of two types. A spectrum is basically of two types. First is emission spectrum. Second is absorption spectrum. Emission spectrum is further of two types. One is the continuous spectrum. Another is line spectrum. Now, what is the emission spectrum? So, emission spectrum is obtained when radiation from the source are directly analyzed by a spectroscope. So radiation of the source directly analyzed by a spectroscope. Now what's about the second one, about the emission spectrum? So it consists bright colored lines separated by dark space. Now the third property it may be continuous or discontinuous. It may be continuous or discontinuous. So what's about that? We'll just discuss about the continuous and discontinuous. Basically emission have this, so one is the continuous and the other is line spectrum. This is discontinuous. So we'll just discuss about these two. So absorption spectrum is what? So white light when it not directly analyzed by a spectroscope. So white light crosses through first crosses through the substance and then transmitted light analyzed by a spectroscope. So there is a difference over here. So absorption spectrum is what? So it's not directly analyzed, whereas the emission spectrum is directly analyzed. Now emission spectrum, it consists dark lines. So having dark lines which is not present in what emission spectrum. So it have the dark lines. Now next one, it is always a discontinuous. So what we studied the difference between emission and absorption spectrum. Now we will study one by one actually what is the continuous, what is the line spectrum, and what is the absorption spectrum with example. Now let's start with the emission spectrum. And first one is emission spectrum. Emission spectrum. So when the radiation emitted from the source, like suppose we just discuss in emission spectrum, we will just discuss about the continuous spectrum. Continuous spectrum. So continuous spectrum is what? Suppose we just take a white light. So this is a white light, and it crosses through the prism. This is a prism. When it crosses through the prism, then it deviates in 7 colors. 1, 2, 3, 4, 5, 6, 7. This is the Vibgyor. No? And when you obtain this on a photographic plate, this is known as continuous spectrum. 1, 2, 3, 4, 5, 6, and 7. So this is VIBGYOR, Vibgyor. So this is a photographic plate we have taken. Photographic plate. So this is emission spectrum. So this is a continuous spectrum. Now we will discuss about line spectrum. So what happens in the line spectrum? Line spectrum. Second one is the line spectrum. Line spectrum is what? Line spectrum. So line spectrum is what? So in this, what we do, we don't passes the white light directly through the prism. First, we suppose we just take the NaCl, sodium chloride crystal, and we heated it, na? And whatever the light comes out, na, that light passes through the prism. What the light comes out by the burning of NaCl, that light passes through the prism, and what we observe only 2 lines over here, and that is the of the wavelength in between 5896 in case of NaCl. It may be the, if you use some other salt, then it may be the different one. So it depends upon the wavelength of the salt we have taken. So we get 2 lines in between 5896 angstrom and 5890 angstrom. So this is 2 yellow lines we obtained. So this is a line spectrum. So line spectrum is a what? It is a discontinuous spectrum because it is not observed directly through the spectroscope. First, we just take salt, we burn it, and whatever the transmitted light that is passes through the prism, and then after when you obtain these radiations on the photographic plate, that is known as the line spectrum. So emission have the 2 types. First is the continuous spectrum, second is the line spectrum. Now we will discuss about the absorption spectrum. So what is the absorption spectrum? Spectrum. So what's about the absorption spectrum? So now in this absorption spectrum, this is what we studied. This is a discontinuous, always discontinuous spectrum, and always dark lines is formed. No? So suppose we take a white light. We take a white light. This is white light, and when the white light passes through the NaCl solution, we just take a tube which have the NaCl solution. Na? So what happens now when the light passes through the NaCl solution, and that light is passed through the prism. Na? So we obtained this radiation on photographic plate. So VIBZYOR in place of Y. In place of Y, Y means yellowish color. In place of Y, there is some dark lines formed. Dark lines formed. Otherwise, all colors are visible. All color, whatever the color, it is visible. So this dark lines formed. So it means this color is absorbed by the white light, or the NaCl, or we can say the NaCl solution have absorbed the white yellowish color, and it did not transmitted the yellowish color. So that's why we are not able to see the yellowish color on the photographic plate. So this is the absorption spectrum and the emission spectrum. Now hydrogen, there is one more, that is the hydrogen spectrum. So hydrogen spectrum is a spectrum. This is also a type of emission spectrum. This is a type of emission spectrum. Okay. So when hydrogen gas is have been taken in a discharge tube, so when you take the hydrogen gas, in a discharge tube at low pressure, and the light emitted on passing electric discharge, and whatever the light emitted on passing electric discharge is observed by a spectroscope. When it is observed by a spectroscope, then some series of different lines is observed. These lines form a hydrogen spectrum. Have a look here. So when you take such, we can say, wait a second. So if you, how will you draw this? Drawing is the most important part. So when you take the hydrogen gas, so you will say only one electron is there, so how the different lines can form? Basically it is not one electron, it is one electron is there, but radiation is so many radiations are there. So suppose we take from nth orbit, or from infinity we can take, but we are starting from the 8th orbit, and so when the radiations falls on the first orbit, 3, 4, 5, so radiation is formed as the first orbit. So this form Lyman series. This is form a series. This is the Lyman series. When the radiation falls on the second orbit, suppose you have started from the sixth one, n is equal to 6 or n is equal to 1 2 3 4 5 5. So 5. So n is equal to on second orbit. So it will form a Balmer series. Balmer series. If it forms on Lyman-Balmer partition, n is equal to 3, then partition, then n is equal to 4 bracket, and n is equal to 5, that is fund or P fund, we say P fund. So these 5 series are formed. Lyman series formed in the ultraviolet region, whereas Balmer series formed in visible region, and these 3 are formed infrared region. So this is near infrared, and far infrared, just like this. So the thing is what? So when the electron jumps from first orbit to when the radiations jump from first orbit, have a look here. We have the Lyman series. In case of Lyman series, so the radiation will always jump from n will be over here, it will be 1, but n2 will be, this n1 will be 1 and n2 will be, it may be 2 3 4 5, anything it may be. It will jump from first to n1. So from Balmer, for Balmer series is the n1 will be 2, this is the second orbit, and n2 will be always 3 4 5 6, anything it may be. Now in the similar manner with the partition, we have partition series. So n1 is equal to 3 and the n2 is equal to 4 5 6, bracket BRACKETT bracket series, and the n1 will be 4 and the n2 will be 5 6 7, just like this. For font, P font or the font, we say font series, and the for font series n1 will be 5 and the n2 will be, it may be 6 7 8, anything it may be. So this is about the hydrogen spectrum. So this is hydrogen spectrum is basically is a type of emission spectrum, and when you absorb the hydrogen gas in a different series, so it forms a different lines, or it forms a different series. So the name of the series are Lyman series, Balmer series, partition series, bracket, and font series. This is formed in the ultraviolet, visible, and the infrared region, just like this. So this is about This is about the hydrogen spectrum. Some questions come from this, which is related to the Bohr's atomic model. So at that time, it will be helpful for solving numerical. Now, so but you should always keep in mind the n1 and n2 values. N1 values for the Lyman, Balmer, partition, bracket, and font. N1 is always fixed. For this one is 1, Balmer is 2, for partition is 3, bracket is 4, and the font is 5. N2 may vary how the electron will jump from one orbit to other, so it will vary. Now we will just discuss about the shapes of atomic orbiter. Shapes of atomic orbitals. If you remember, as we have how many sp, df. Now these are the subcell, and it have how many number of orbital, if you remember, then S have only one orbital, P have 3 orbital, and its name is Px, Py and the Pz. D have 5 orbital, and this is named as dxy, dyz, dzx, dx square, y square. Wait a second. Dx square, y square, and dz square. Now, if we have not, this is not a part of syllabus, so we will not discuss about this. So we will just discuss about the SPD. Yeah? So we just say it's not fixed. So S is what? S is basically S is spherical. P the name of the principal, D diffused, and F is not fixed. So S is spherical in shape. P is dumbbell. Now, dumbbell is just like this, and D is double dumbbell. Double dumbbell is just like this. You can say double dumbbell. Now we'll just discuss about one by one. So S is spherical is very common, but now we'll start with the P, and the P have how many? Px, Py and Pz. This has Px, Py and Pz. Yeah? So when we just discuss about the Px, Py, Pz, so we just draw the structure just like this on a coordinate. This is the x-axis, y-axis, and this is suppose a z-axis. Now, if the dumbbell form on the px, just like this, so this is the px. Now, if the dumbbell form, all are formed on the axis, so you should keep in mind. So x, y, z, or even I put anything x, y, z, or this is the x and y, and this is a z. If one dumbbell will form on a y axis, then it will known as py, and if the dumbbell will form at the z axis, x, y, z, if the dumbbell is formed at a z axis, so this is known as pz. So px, py, pz all are formed at its what axis, px, py, p and z axis. Now we'll just discuss about the shapes of d orbital. D have 5 orbitals. How many orbitals? D have 5. 1, 2, 3, 4, 5. This is the dxy, dyz, dzx, dx square, y square, and this is the dz square. Okay. So now we'll just discuss. I want to dxy, dyz, dzx. These all are formed at where? It will form an axis of plane. It will form such planes. These two will form at axis. These 4 are asymmetrical. Asymmetrical, and this dz square is a symmetrical one. Symmetrical one. So what the meaning of this? We'll just discuss one by one. So basically, let's start with the dxy. So we just draw a coordinate. This is x, this is y, and this is z. So we are discussing about dxy. So this plane is known as planes for x. One dumbbell is over here, and y. So this plane is for y. So we can say this is a y. So if such type of structure is formed, then this is a dxy. Now what's about the next one? next one we have, this is the x, this is the y, and this is z. Now d y z, d y z. So have a look here. This is what he told, y planes, and this is the z planes. So if the dumbbells are formed, D have the double dumbbell. So dumbbells are one dumbbell is formed at the y plane, one at the z plane. Then this is the d y z. Now next one we have to draw. This is the x, this is y, and this is z. Now this time we have to form dxz, dxz. So if one dumbbell formed at x-axis, so this is your x-axis, other is formed, sorry, one dumbbell is formed x planes and other is formed at z plane. Z is this one is the z plane. So this is what dyz. Now the next one, this is the x, y, z. Now this time dx square y square. So this is what I told you. Then this is this will form at axis. So we have two dumbbell form at x, two axis of one axis of x, one axis of y. So one dumbbell will formed at x axis, other dumbbell will form at the y axis. So this is what dx square y square. These all three, 1, 2, 3, these are on planes. This is on axis, and the last one is also on axis. So last one is, this is x, y, and this is z, and last one is the dz square. So dz square. So we can also consider it. Suppose we can also write just coordinate can be written as dz square. So they are saying dz square. So we can 2z. So this is the z. Now this is, so one on the z, and other will also rotates on the z axis like this. So this is what, this is your dz square. So what I told you, these two are formed at axis, these three are formed at planes. These four are asymmetrical, where this one is a symmetrical one, because rotation takes place at its own axis. So this is the shapes of atomic orbitals. Now we'll just discuss about one thing that is known as node. So node is what? Node is basically, it is told that node is nothing. This is basically no electron zone. Nodes are the place. This is also known as no electron zone, where the possibility of finding the electron is 0, or simply we say nodal surface. Nodal surface. So now this nodal planes, or the no electron zone, we can say this. So how just find out is how many types are. So basically these are nodal planes is of two types. First is the number of spherical or radial nodes, spherical or radial nodes, and second is planar or angular node, planar or angular node. Now there are some formula. So number of spherical node or radial node that is equal to n minus L minus 1, where the n is the principal quantum number. N is what? Principal, if you remember, principal quantum number. L is what? Azimuthal quantum number. Azimuthal quantum number. Na? Acha, there is some other. We have number of planar or angular node in any orbital, that is equal to L. So what the azimuthal quantum number, that is. And so the total number of nodes is what? Total number of nodes, that is equal to what you say, that is equal to sum of this one. Na? Suppose this is 1 and this is 2, so 1 plus 2, na? Or we can use A plus B, like A and this is a B, na? So total is A plus B. A is what? N minus L minus 1 plus B is what? L. So L is cancelled, so it will be what? N minus 1. So you can find out the total number of nodes just like this. So basically nodes is what? Nodes is no electron zone. So suppose where the probability of finding the electron is 0, that is known as nodes. Now have a look here. If you want to find out the number of nodes in any orbital, so we simply they are in question, they ask you ki find out number of nodes in any orbital, that will be equal to n minus L minus 1. So this will indicate the radial nodes or spherical nodes. Suppose if you want to find out in 1s, what is the number of nodes? So we will take the help of if you remember, for SPDF the individual value of L is 0, 1, 2, 3. So for this one, this 1, 2, 3, this 1 is indicates n. So n is 1 minus L is for L is 0 minus 1. So 1 minus 1 0. For 2s, how many? 2s is 2 minus 0 minus 1, means 2 minus 1, that's 1. And for 3s is what? 3 minus 0 minus 1 is number of nodes is 2. And number of nodes in 4s is 4 minus 0 minus 1, that is equal to 3. Now have a look here. 1s, this is 1s, huh? This is 1s, this is 2s. So in between 1s and 2s, this space is the no electron zone. So there is only one no electron zone for 2s. For 3s, let's think about 3s. So this is 1s, this is 2s, and this is 3s. So 1s, 2s and 3s. For 3s, there is two spaces between 1s and 2s, 1, and between 2s and 3s, 2. So there is two number of nodes is present in 3s. And in the similar way, 1s, 2s, 3s and 4s. So for this one, this is your 1s, this is 2s, this is 3s, this is 4s. Then 4s, there how many no electron zone is? 1, 2, 3. So your answer is 3. So this is regarding the number of nodes, shapes we have discussed today. So in next class we will discuss some more concept and some more topics about this chapter or the other chapter. So till then, goodbye, take care.